Hi, this is Richard Hicks, founder and principal consultant at Richard M. Hicks Consulting, where we specialize in enterprise mobility and security infrastructure. We provide consulting services for secure remote access and public key infrastructure projects. In this video, I'm going to demonstrate how to request and install a TLS certificate to support the Secure Socket Tunneling Protocol, or SSTP, on a Microsoft Windows Server Routing and Remote Access Service, or RRAS server. We'll begin by creating a Certificate Signing Request, or CSR. This creates a public and private key pair on the VPN server. We'll submit this public key to a Public Certification Authority, or CA, for signing, and once we have the signed certificate back, we'll import it along with any root or intermediate certificates into their respective certificate stores. After that's completed, we'll assign the new certificate to the SSTP listener on the VPN server. When renewing an existing TLS certificate for SSTP, the best practice is to use a new key pair for optimal security. With that, the procedures described in this video can also be used for an existing deployment when it comes time to renew the existing TLS certificate for SSTP. Also, in this video, I will be creating a TLS certificate using elliptic curve or EC key pair. EC is highly recommended in this scenario as it provides better security and performance when compared to traditional RSA certificates. I'll also demonstrate the procedures for both server with desktop experience, or server with a GUI, as well as server core. So let's begin by creating a certificate signing request, or CSR, on our Windows server with a GUI. We'll start by opening up the local computer certificate store, and the best way to do this is to just click on Start, and then just type in certlm.msc. Expand the personal computer store and highlight certificates. Right-click anywhere in the blank space there, choose All Tasks, Advanced Operations, and Create Custom Request. Click Next. Select Proceed Without Enrollment. Click Next. All the defaults here are OK. Go ahead and click Next again. And here's our custom request. Now, we need to submit some information with this, so we're going to click on the arrow here next to Details, and then click Properties. Here we're going to enter a friendly name, and I generally put in the FQDN or the subject name of the certificate just to make things easier. Then we'll click on the Subject tab, and in the Subject Name section from the Type drop-down list, choose Common Name and enter the public FQDN again. I'm going to put this on my clipboard now because I'm going to enter it probably a couple of more times here. So we'll click Add, and in the Alternative Name section, in the Type drop-down list, select DNS, and go ahead and put the public FQDN there as well. Click Add. And of course, you can add additional subject alternative names here if you wish. If you plan to use this certificate for more than one FQDN or host name, you can certainly provide multiple names here as well. Next, we'll select the Extensions tab, and then we'll expand the Extended Key Usage section, highlight Server Authentication, and click Add. Now we'll go to the Private Key section, and here under the Cryptographic Service Provider, we'll uncheck RSA, and then we're going to scroll to the bottom, almost all the way to the bottom. And what we're looking for here is ECDSA P256 for the Microsoft Software Key Storage Provider. Next, go to Key Options, and optionally you might want to make the private key exportable. This is a good option here for two reasons. First, if you plan to put this certificate on more than one VPN server, for example, if you have 4, 5, or 6, or 20 servers in a cluster, or maybe in different geographic locations, you may want to just create one certificate request with all the subject names in them, and then distribute those to those servers and import them there. You can do that by marking the private key as exportable, and then once you're done, you can export the certificate and the private key and import that on all the remaining servers. It's also not a bad idea to do for archival purposes. When you get your certificate back, you can mark the key exportable, you can export it, and then store that in a secure location along with the private key and the password, and you'll have that for future reference. If you need to rebuild the server quickly, you can just simply re-import the certificate and private key rather than having to go through the whole process of creating another CSR. So click OK, click Next, and then provide a location for the file name. I usually give it the extension .csr, but it doesn't really matter. It's just a text file. and then we'll click Finish. So next we'll take a look at this in Notepad. And what you'll see is the certificate in base 64 format. Of course, this is not readable to us. If we wanted to take a look at it in readable form, let's open up a PowerShell command window. And we'll navigate to that location. Then run the command certutil.exe and the name of the CSR. And here, what you'll see is all of the information contained in the CSR in readable form. So once this is done, copy the contents of the vpn.csr file and submit that to your public certification authority for signing. So creating a certificate signing request, or CSR, on Windows Server Core is slightly different. Obviously, we don't have access to the GUI, so we'll need to do things a little differently. We're going to start by creating an INF file that includes some of the parameters that we need to supply in our signing request. So I'm going to use Notepad to create an INF file. And of course, I'm going to cheat just a little bit. I'm going to paste some content from off screen. But the INF file should have a minimum of 2 sections. It needs to have a new request section as well as an extensions section. In the new request section, we need to include the subject name in the format CN equals public host name, or FQDN. And in this example, I'm using vpn.richardhiggs.net. You can also include a friendly name field. And also, we want to include the key algorithm and make sure that we specify ECDSA underscore P256. This will ensure that our certificate uses an EC, or elliptical curve, private key. The key length is 256, and then the machine key set value needs to be true so that it will work with our local computer certificate store. And although not shown here, if you want to make this certificate exportable, add exportable equals true in the new request section. In the extensions section, we're going to specify the value as shown here, and this is essentially our subject alternative name values. When creating a certificate request, it is a best practice to include the subject name as the first subject alternative name entry. So we have that defined here. You'll see that the value is DNS equals subject name. If you want to specify additional subject names, and you can do that, you just simply copy this entire line and paste it, and then change the name of the DNS value. So you could add VPN2, VPN3, VPN4, what have you. Once that's done, go ahead and save the file. And now we're going to use this INF to build our CSR, our certificate signing request. To do that, enter certrec.exe-new, and then the name of the INF file, and also the name of the CSR file. And once again, the CSR is essentially just that information in base 64 format. If we want to look at this in human readable output, we of course can use certutil for that, just like we did on server GUI. Once that's done, copy the contents of your CSR and submit that to your public certification authority for signing. Once you've received the certificate back from your public CA, we'll need to import it into the local computer certificate store. Once again, best way to do this is to click on Start, type in certlm.msc, expand Personal and Certificates, and then just right-click, choose All Tasks, Import. Choose Next, click Browse, and select the certificate that was returned. Click Next. Place all certificates in the following store and make sure that Personal is selected here, and then choose Next and Finish. Click OK, and now you'll see that we have a public SSL certificate. Double-click on the certificate, and you'll notice now that the certificate has a private key. Next, click on the Certification Path tab and ensure that the certification path is complete. There should be no errors or warnings here. It's possible that depending on where your certificate was obtained from, you may need to install root or intermediate certificates on the server. Those should have been supplied by the CA when they issued your certificate, so you may need to do them here as well. That's easy enough. You would just simply go to the Trusted Root Certification Authority store, highlight certificates, right-click All Task Import, and then import the certificate that they provided for you. Make sure that you import them into their specific stores. So trusted root certs go in this store, and intermediate or issuing CA certs would go in the Intermediate Certification Authorities store. The important thing to note is that there should be no root or intermediate certificates in this personal certificates computer store. If that's the case, they need to be moved out to their respective stores. On Windows Server Core, once you receive the certificate back from your public CA, copy it to the server, and then we'll import it using PowerShell. So here I've placed the certificate on the C drive. So to import it, we'll just run the following PowerShell command: import certificate -file path, and then the name of the certificate file. Also, we need to provide the certificate store location, so we'll use the command -cert store location. And we'll provide the local computer certificate store. Next, we'll verify the certificate has a private key, but first let's copy the thumbprint for the certificate. And then we'll run the following PowerShell command. Of course, this command only returns the certificate object itself. To view all of the properties of the certificate, and specifically the private key, we'll do an up arrow, and we'll pipe that to the format list command with the star filter property. Here you'll see that the value of has private key is set to true, and that's critical. So on Windows Server Core, it's important also to check the certification path for our certificate. We can view the certificate's certification path by using certutil-verify on the certificate that we imported previously. And here you'll see we have an incomplete certificate change, just as it shows here. And that's obvious because I didn't import my root or issuing CA certificate that I got back from DigiCert when I got this certificate. So I'll do that now. I've copied them over to the C drive, and I'll import them using PowerShell and the import-certificate command. We'll start with the root CA certificate. And we'll import this into the root CA store. And I'll repeat this process for the issuing CA and put that in the local machine CA store, or the trusted issuing CA store. So let's check that certificate once again with certutil-verify. And no issues to report. Now you'll notice there might be an error here for revocation. You could ignore this. My lab does not have access to the internet, so obviously the revocation check is going to fail. But you shouldn't see these issues in a production environment. Now that we have all the certificates imported, let's assign the certificate to the SSTP listener. To do that, let's open the Routing and Remote Access Management console. We'll right-click on the server and choose Properties. Go to the Security tab. And down here in the SSL certificate binding section, select the certificate from the drop-down list. Now, you might have more than one certificate with the same subject name. That's okay. We'll select the first one and we'll click View, and we'll make sure that this is our public certificate. And you'll see here that this is issued by GeoTrust, so that is the correct certificate. Just to make sure, though, let's take a look at the next certificate, and you'll see here if we click View, this was issued by my private internal CA. So obviously this is not the correct certificate. So we'll click View once more just to make sure. Click OK. We'll click OK again, and then we'll be prompted to restart the remote access service. Now it's important to understand that anytime you restart the remote access service, any active sessions will be disconnected, meaning if you're going to make this change, probably best not to do it during production hours. On Windows Server Core, we'll use PowerShell to assign the TLS certificate to the SSTP listener. But first, we need to find out which certificate we want to assign. And so let's take a look at the certificate store now. And you'll see that the local computer certificate store on this server has 2 certificates. So we need a little bit more information to determine which one is the correct certificate. So here you'll see that the first certificate is actually issued by my internal private CA. So that's not the certificate that we want to assign to the SSTP listener. It's actually this certificate that was issued by DigiCert. So I'm going to copy the thumbprint, and then I'm going to create a certificate object as a variable. And then we'll run the cert command just to see that it's actually there, and that looks good. And then finally, we'll use set remote access to assign the certificate. And once that's complete, if you use the pass-through command, you will see the certificate thumbprint and the certificate assigned correctly to the SSTP listener. Of course, to finalize this change, we need to restart the remote access service. To ensure the highest level of security for your SSTP VPN connections, be sure to download and run the Optimize VPN TLS configuration script found in my Always On VPN GitHub repository. Running this script will disable insecure TLS protocols and optimize TLS cipher suites to enhance security and performance. Again, you can find this TLS optimization script at github.com/richardhicks/AOVPN. After you've run the script and restarted the VPN server, visit the Qualys SSL Labs server test site at sslabs.com/SSLtest to review the TLS configuration for your VPN server. If you follow the guidance provided in this video, you should receive an A rating as shown here. Also, if you're interested, you can fully automate the process of enrolling public TLS certificates by using Let's Encrypt. Visit rmhci.co/Let's Encrypt for more details. And of course, if you'd like to learn more about Always On VPN, as well as other mobility and security solutions, visit my website at directaccess.richardhicks.com.